Good afternoon. Here we will see some simple assembly language programs using 8051 microcontroller, which gives the understanding of the operation of different instructions and understand the logic behind the particular program. So first the statement of the program describe that what should be done is given, and then the solution is given, which describe the logic law which gives the logic law how it will be done, and the last code is given. So first program is exchange the content of, or the first statement is exchange the content of FFH and FF00H. Now what is the solution? Here one is internal memory location and other is external memory location. So first the contents of the external memory location, that is FF00H, is loaded in accumulator. First the content of external memory location is loaded in accumulator, then content of internal memory location FFH is saved first, and then content of accumulator is transferred to FFH. First we have to first the content of external is loaded in accumulator, then content of internal is saved, and then content of accumulator is transferred to FM. Now the saved content of FM is loaded into accumulator and then it is transferred to FFH. So here is a program that move dptrh, that is it take the address in PTR. Then the next step is we have to get the content of 0050H in A, because in DPTR the content of 0FF0H, then the save the contents of then save the contents of 50H, then move to 50H. So this is the simple program of transfer. Then the next is duplication and subtraction. So store the higher nibble of R7 into both the nibbles of R6. So solution is that first we shall get the upper nibble of R7 in R6, and then we swap the nibbles of R7 and make our operation with R6, so the upper and lowers are duplicated. Now here is the program. First the contents, get the content in accumulator, then mask lower bit and send it to R6, and again exchange the upper and lower. Then the next is the division and data transfer. So divide the contents of R0 by R1. Then we have to store the result R2 in the answer. In R2 there will be answer, and in R3 there will be reminder. Then again restore the original contents of R0. So here is the program. So after getting answer, to restore the original content, we have to multiply the answer with divider and then add the remainder in that. So first we get the contents of R0 and R1, then contents of R1 in B, then divide A by B, then this division result is stored in register R2 and remainder will be in R3. Now again get the content of R1 in register B, then multiply both A and B, then remainder will be stored in A, and finally store the contents of R0. So this program is for the division and multiplication. Then the next is the comparison programs. Then here we have to find out how many equal bytes between the two memory blocks. So here we will compare each byte one by one from both the block and increase the count every time when equal bytes are found. So first we have to initialize the counter by 10D, then get the initial location of block 1 and block 2 and equal the byte counter which starts from 0. Then get the contents of block 1 in accumulator, and then these contents of accumulator are moved to B. Then contents of the block 2 in accumulator and compare both if equal. Then increment counter, otherwise go for the second number, and so on. And the next is the interrupt counting subroutine and scan and multiply. So here the crystal frequency is 12 megahertz. So make a subroutine which will generate a delay of exact 1 millisecond, and we use this delay to generate a square wave of 50 hertz on pin number port 2.0. So 50 hertz means what? 20 millisecond, and because of square wave 10 millisecond on time and 10 millisecond off time. So first here load 10D in R6, resistance R6, then 1 millisecond delay, called delay, then send 0 to the port 2 pin and load 10D in R6, then again call delay, continuous loop, and so on. So here because of the square wave 10 millisecond on time and 10 millisecond of off time, so for 10 millisecond we shall send 1 to the port pin, and for another 10 millisecond 0 in continuous loop. So here 0 is sent to the port 2 pins in another 10 seconds. And this is a continuous loop.